9702 February March 2021 paper 1 wherein two the topic is diffraction grating and the question number is 29. A beam of red laser light of a wavelength 633 nanometer is incident normally on the diffraction grating with 600 lines per millimeter. The beam of red light is now replaced by a beam of a blue laser light of wavelength 445 nanometer, and the replacement diffraction grating is used so that the first order maxima of the blue light appears at the same position on the screen as the first order maxima of the red light of the original laser light. How many lines per millimeter are there in the replacement diffraction grating? So, first of all, we know the formula of differential grating n lambda equals d sine theta. D is what? D is the the slit separation. N is the number of order of maxima, wavelength, and the angle between the order of maxima. So first thing first, let's say the number of order of maxima for the blue light, for the red light first is n1, and lambda 1 is for the red light, d is the slit separation, and sine theta is the angle between the order of maxima. So that means for red light is n1 lambda 1 equals d1 sine theta, and for blue light it will be lambda 2 n2 lambda 2 d2 sine theta, right? The d2 sine theta. So if the order of maxima placement is the same in both sides, that means the angle is the same. Why? Why? Because the order of maxima is depend on the angles. So if the angles are the same, the position will be the same. So that means n1 lambda 1 over d1 equals sine theta is equals to n2 lambda 2 over d2 sine theta. So that means sine theta is common in both sides. So we will equate both equation, which is n1 lambda 1 over d1 equals to n2 lambda 2 over d2. The next thing is the n1 is the order of maxima in the same position. That means n1 and n2 are also same. So that means lambda 1 over d1 is equals to lambda 2 over d2. Okay. Now, uh, 6 lambda 1 over d1 means 631 over d1. We don't know the d1, but we do know the number of lines per millimeter, which is d is the, as we say, d is the reciprocal of n, where n is the number of lines per millimeter, right? So 631 over 600, right, equals 445, which is what, and by the way, nanometer is in same in both cases, so we will not have to write this. So 633 over 1 over 600 is equals to 445 over 1 over x. X is what? The number of lines per millimeter of the second diffraction gratings. So after solving, we will get what? We will get x is 853, which is approximately 850 lines per millimeter. So that is option D. So what is the catch? We if for this problem, the problem is we need to understand if the placement, the position of order of maximum is same, so that means angles are the same, and n number order of maxima are the same. So n and theta both are the same, right? So, and the next thing is the number of lines per millimeter relationship with the slit separation, which is reciprocal. So these two things are required along with the formula. So this thing we will, by this we will get 850 lines per millimeter.